Hi, it's me, Tim Dodd, the Everyday Astronaut. Welcome to the 2018 Astro Awards, a time where we reflect on all the exciting things that happened throughout the year in spaceflight and space discoveries. This isn't anything official, just a time to take a look at all the awesome science, discoveries, engineering, and achievements made in the past year. We took polls here on YouTube and on Twitter and also on Reddit to get some of your favorite missions, and now we're just gonna take a second and soak them all in. So without further ado, may I present to you the 2018 Astro Awards. Hello and good evening, ladies and gentlemen, and welcome to the second annual Astro Awards, the night of the biggest stars. Yes, even UY Scuti and Betelgeuse and VY Canis Majoris, and yes, even NMLI Cygni made it. Oh, they're just beautiful, aren't they? Yes, I'm definitely gonna be saying that joke every year, so you better get used to it. This is our chance as the general public to lift up, celebrate, and thank those who dedicate their lives to furthering our knowledge and understanding. 2018 was an incredible year for spaceflight and space discoveries. As a matter of fact, it was the busiest year of launches since 1998. So clearly, we have a lot to talk about. Now before we get started, let's take a few moments to reflect and remember some great people, some missions, and programs we had to say goodbye to this year. Starting with a few important people who dedicated their lives to space. They'll forever be remembered, and we cannot thank them and anyone who helped them achieve greatness enough. And although clearly not as tragic as losing a loved one, we also saw the end of a few important missions and programs this year. Yeah, I did put opportunity in there because although the mission isn't officially over, it's in a pretty deep sleep, and I wanted to make sure we potentially send it off on a really high note. You know, tucking it in into a nice, deep, and cozy sleep. So to all those who dedicate huge portions of their lives to these missions and programs, thank you. Each mission has helped shape our understanding of our universe and helped us push the boundaries of our knowledge. It's super fun for all of us to casually sit back and watch a rocket launch or see data flowing from a probe a billion kilometers away, but we sometimes forget that there's teams of people who are tirelessly working on each and every aspect of that successful mission. So again, thank you. And lastly, before we get started, I wanted to give a quick honorable mention to the Dear Moon announcement with SpaceX and Yusaku Maezawa. It's incredibly inspiring, almost Willy Wonka-esque, for a Japanese billionaire to be gifting a handful of artists a trip around the moon. Since we're years and years away from seeing that flight actually happen, we'll just leave it as a thank you, Mr. Maezawa, for helping to inspire a generation of artists. That truly means a lot to me personally as an artist and a musician, and I think this mission will certainly go down in the history books. All right, on with the show, starting off with our first mission. Voyager 2? What? We're starting off on a pretty weird foot here if a probe launched over 40 years ago is in the greatest space events of 2018. Well, the fact that it launched over 40 years ago is why it's so incredible that it's still making scientific discoveries today. As a matter of fact, Voyager 2 became the second spacecraft to make it beyond the sun's protective magnetic field, marking its entrance into interstellar space. But unlike Voyager 1, which entered interstellar space in 2012, Voyager 2 still has working instruments on board that'll provide a first-of-its-kind observations of space beyond our solar system. Although this boundary in space might seem a bit arbitrary, we can see a big, huge spike in galactic cosmic rays and a sudden drop in heliospheric particles as the probe made it beyond the heliosphere. The Plasma Science Experiment, or PLS, on board Voyager 1 stopped working in 1980. So to have it remain active during this transition into interstellar space is an amazing feat of engineering. Some fun facts. It spent over 41 years in space, traveled over 17.7 billion kilometers from the sun, and is traveling at a crazy 55,000 kilometers an hour relative to the sun. It's visited 4 planets, Jupiter, Saturn, Uranus, and Neptune, and it's now so far away it takes 16.5 hours for communications to make it back here at Earth. That's traveling at the speed of light. Voyager 1 and 2 will both continue operating until their onboard radioisotope thermoelectric generators, or RTGs, stop producing power. They're currently losing power at about 4 watts per year, and the spacecraft aren't expected to have any science experiments operating past 2025. And although they might not hold that much scientific value with their instruments turned off, they might continue to operate, transmitting data into the deep space network until 2036. Whoa. Not bad for a probe that was supposed to have a 5-year primary mission. It's absolutely jaw-dropping to have a 41-year-old probe still producing priceless, new, and astonishing scientific data. So huge congrats to NASA's Heliophysics System Observatory, JPL, who built and operates Voyager, and all others involved. What an incredible legacy. Okay, Tim, you're starting off the greatest moments of space in 2018 on a weird page here, bud. First a 41-year-old probe, and now a launch failure. How is this great? Well, hold up, because anytime humans risk their lives for exploration and make it home safe, I consider that successful. So let's do a quick recap. On October 11th, 2018, Commander Alexei Ovchinin of the Russian Space Agency and NASA's Nick Hague boarded a Soyuz spacecraft headed for the International Space Station for Expedition 57. This was a very routine launch of a Soyuz spacecraft, this being the 10th flight of a newly revised 6th generation version of the Soyuz spacecraft. But Soyuz has been in service since 1966 and has flown almost 200 times. And this current generation of the Soyuz rocket, the Soyuz FG, yes, both the rocket and the spacecraft are called Soyuz, has flown 65 times to date in total. But the Soyuz/R7 rocket family it stems from has launched nearly 2,000 times. So when something goes wrong with a vehicle with such an incredible launch history, it's pretty noteworthy. The launch went off perfectly at 8:40 UTC from the Baikonur Cosmodrome in Kazakhstan. After only 117 seconds of flight, the 4 strap-on rocket boosters deploy simultaneously from the core stage in a beautiful formation known as the Korolev Cross, named after Soviet rocket scientist Sergei Korolev. Well, at least that's what's supposed to happen. This time, one of the 4 did not deploy properly. A sensor that was supposed to trigger a LOX valve to open up, which then cleanly separates the boosters, malfunctioned. So instead of the top portion of the booster swinging away from the rocket, it slid down the length of the center core, rupturing the tank, which then triggered an abort. Strangely, the Soyuz jettisons its primary launch abort tower 115 seconds into flight, some 2 seconds before stage separation. After this point, there's 4 smaller rocket motors on the fairing of the Soyuz module capable of pulling it clear of a failing rocket. The 4 abort motors pulled the MS-10 and its 2 passengers clear of the failing Soyuz rocket. This led to the spacecraft going into a ballistic trajectory, falling back to Earth. After hitting the atmosphere and slowing down at up to 7 Gs of deacceleration, the Soyuz successfully went through its full landing sequence, which returned the astronauts safely just 20 minutes after liftoff. So to recap, despite a booster scoring another booster like an iceberg to the Titanic, the booster didn't completely explode. It merely ruptured, which of course triggered an abort. The Soyuz capsule safely returned Ovchinin and Hague back to Earth. And at the end of the day, this picture is what makes me realize that this is indeed a great moment in space history. Here's the families hugging their loved ones after a scary close call. This helps reiterate just how important crew safety is as we approach a new era of crewed spaceflight in the United States, and soon India as well. So unfortunately, the MS-10 launch was a failure. But safely returning crew from the edge of space on a failing rocket is always a huge success. And fortunately, the Soyuz has already returned to flight on December 3rd for MS-11. It's a really quick return to flight. So the Soyuz is back, and I was really excited to see this workhorse barely even stutter to get back on its feet. Speaking of putting humans in space, NASA introduced us to the first 9 astronauts who will fly with SpaceX and Boeing starting in 2019. Yes, it's finally getting real. On August 3rd, NASA held a press conference at Johnson Space Center to introduce the crews of the first 4 commercial crew missions. The crews are the following. For Boeing's test flight crew for Bo CFT will be Eric Bo, Chris Ferguson, and Nicole Mann. SpaceX's first test flight crew for DM2 will be Bob Behnken and Doug Hurley. Boeing's first operational missions to the ISS will be CST-1 with John Cassata and Suni Williams. And the crew for SpaceX's first operational missions to the ISS will be Crew 1, which will be Victor Glover and Mike Hopkins. And although we didn't actually get to see a ton of action out of either the Starliner or Dragon 2 capsule in 2018, at least I got to get up close and personal with the training hardware from both SpaceX and Boeing, which was super awesome. I even got to try on Boeing's spacesuit, and I got up close with SpaceX's spacesuit as well, which was super awesome. Seeing the crews actually solidify is really exciting, and it means we're getting closer to finally seeing it happen. Hopefully the demonstration missions for both SpaceX and Boeing happen really early in 2019, so we can stay on track to fly Crew mid-2019. I cannot wait. That'll be some seriously historic flights, as it'll be 8 years since the US has flown humans into space from US soil. Well, actually, this next one might have something to say about that. Virgin Galactic had an exciting year as they got their Spaceship Two VSS Unity spaceplane up and atom, or up and atmo, up and out of the atmosphere-ish. It had been over 3 years since a Spaceship Two spaceplane had seen any powered flights. But finally, Virgin Galactic got back in the saddle on April 5th, 2018, when their second Spaceship Two, the VSS Unity, fired its hybrid engine for 30 seconds. This sent pilots Dave McKay and Mark Stuckey over 25 kilometers in altitude. But that wasn't all for Virgin Galactic this year. Nope, they went on to have 3 more powered flights, clearly ramping up to start flying tourists hopefully in 2019. As a matter of fact, their last launch of this year on December 13th reached a new altitude record of 82.7 kilometers. Now, we can all argue day and night about whether or not 82 kilometers is in space, but to do so would detract from the progress Virgin Galactic has made this year. And not to mention, they still have a little more juice in that bird and might be able to cross the Kármán line, if you really think that'll make your potential suborbital hop that much better. And another exciting fact is Virgin Galactic's next destination isn't space, but hopefully they're going to be moving into Spaceport America in New Mexico soon. No offense to the hollowed ground at the Mojave Spaceport or anything, but I'm sure their customers waiting to ride on Spaceship Two will welcome the beautiful 21st century spaceport. So all in all, I was really excited for Virgin Galactic this year. They're really getting at it lately, and it seems like they're growing more and more confident in their vehicle and getting closer than ever before to flying customers. So huge congratulations to the teams at Virgin Galactic for getting one more final flight in this year, breaking records, and preparing for an exciting future. Osiris-Rex, or the Origins Spectral Interpretations Resource Identification Security Regolith Explorer, should straight up win the Best Backronym Ever award, but maybe of much more scientific excitement, it successfully reached asteroid Bennu at the end of 2018 and has already made some important scientific discoveries. Osiris-Rex launched on an Atlas V 411 on September 8, 2016 out of Cape Canaveral Air Force Station in Florida. After a picture-perfect launch, the 2,100 kilogram probe started its 7-year journey, not only to an asteroid, but to return a sample back to Earth from an asteroid. After almost 2 years of cruising towards its target asteroid Bennu, Osiris-Rex officially rendezvoused on December 3rd, 2018, coming only 19 kilometers away from Bennu and returning some exciting photographs. Not only that, Before the year wrapped up, it officially began orbiting the asteroid, which it'll do for 505 days to map the surface very precisely from only 5 kilometers away. Once the surface is mapped out, the Osiris-Rex team will select a suitable site from which it will take a sample of the surface of the asteroid. Although it's technically not going to touch down, it'll do more of a hummingbird maneuver, hovering just at a nose's reach, suck up a little bit of that yummy asteroid dirt, and then it's going to encapsulate a 60-gram sample and shoot it back at Earth, where it'll eventually re-enter and land in Utah. That's crazy. Okay, that's a long way away, but what I'm excited about in 2018 is not only the fact that the spacecraft made it to its target, but the cool thing is, within a week of it being there, it already began to observe the presence of hydroxyl, which is basically hydrogen and oxygen molecules bonded together. These findings suggest that at one point Bennu, or its original parent body, may have been in contact with water. Now that's exciting. I'm sure we're going to learn an incredible amount from Osiris-Rex in the upcoming years. And I'm sure the teams at NASA's Goddard, University of Arizona, and Lockheed Martin who built the probe are all super excited to keep exploring Bennu and return valuable data. So good job to all of you involved. So speaking of going out and sampling from celestial bodies in our solar system, another exciting milestone happened this year. The Japanese space agency, JAXA, has a sample return mission all of their own, and it's Hayabusa 2, an exciting follow-up to, you guessed it, Hayabusa 1. Hayabusa 2 launched on H-2A rocket from the Tanegashima Space Center in Japan on December 3rd, 2014. A year later, it did an Earth flyby that flung it out towards the Ryugu asteroid, which didn't intercept until this year, 3.5 years after its launch. Hayabusa 2 builds on the success and learned from the failures of Hayabusa 1, which landed on an asteroid in 2005. But this time, JAXA packed this thing with loads of other payloads for remote sensing, sampling, and even some mini rovers. This thing is like the Swiss Army knife of spacecraft. So not only did we start getting some crazy, gorgeous images like this, but Hayabusa 2 has already deployed 3 rovers. My favorite thing about the rovers cleverly named Rover 1A, Rover 1B, and Mascot, is that they're rovers that don't have wheels. Nope, no wheels, no tracks, no legs. They just hop. They're like the Mexican jumping beans of rovers. They rotate a mass really quickly, and that torque makes them hop. It's crazy. It's an effective way to actually move around in a very, very low gravity environment. There will also be Rover 2, which will deploy sometime next year. All in all, there's so many sensors and instruments that'll be on the Ryugu asteroid, we're going to get a ton of valuable science. I'm definitely excited to see what all comes out of this mission. So great job to JAXA and the German Space Agency and the French Space Agency and all others involved in this mission. Remember at the beginning of this video when we had a little mini tribute that featured the Kepler Space Telescope, whose mission ended this year? Well, Kepler was an incredible space observatory that was responsible for taking the idea of exoplanets or other planets orbiting other stars from a rare observation into an incredibly common observation. This forever changed how we think about exoplanets. Well, with the success of Kepler, NASA was excited to pick up the TESS telescope from an MIT proposal for their Explorers program. Why were they so excited? How does the exoplanet hunting satellite sound to you? I thought so. Fast forward to 2018 and SpaceX launched the TESS observatory from Space Launch Complex 40 in Cape Canaveral Air Force Station in Florida on a Block 4 Falcon 9 booster on April 18th. TESS is impressively small, only 362 kilograms, which allowed for a medium-class launcher like the Falcon 9 to get it out on a highly elliptical orbit around Earth. TESS will take a similar approach to Kepler, observing planets transiting in front of the stars they orbit. So basically, by looking at a star and watching it dim just a little bit, scientists are able to accurately determine a shocking amount about an exoplanet. The coolest thing about TESS is that it can scan 85% of the sky at once. So to put that into perspective, in its 2-year lifespan, it's expected to observe 20,000 exoplanets, which is crazy considering since we first observed an exoplanet in 1992, we've observed 3,800 exoplanets. Okay, let's put that another way. In 26 years, we've observed 3,800 exoplanets. And now in just 2 years, TESS will observe 5 times that. TESS already began some observations in July by finding a comet, and then in August it officially began taking images, and by September it already discovered a super-Earth. So congrats to NASA, MIT, Orbital ATK who built the spacecraft, and SpaceX for successfully delivering this exciting probe. I cannot wait to see what happens next year. Expect some amazing science from this mission. The Indian Space Agency, ISRO, made some huge strides in 2018 in their human spaceflight plans. That's right, maybe you don't know, but India hit 2 big milestones this year and firmed up plans to send their first Vyamnauts, Vyam meaning space in Sanskrit, by 2022. The first big milestone was doing a pad abort of their Gaganyaan crew spacecraft on July 5th. Now, pad aborts are an important milestone of any spaceflight endeavor, as we've seen SpaceX, Boeing, Blue Origin, and others do before they even consider putting anyone on board. The next exciting thing was the successful flight of their GLSV-MKIII rocket with higher thrust engines. Now, don't confuse this with the GLSV rocket, which is basically an entirely different rocket. The GLSV-MKIII is what they'll use to launch their Vyamnauts. The GLSV-MKIII is an incredibly advanced vehicle with 2 solid rocket boosters, an RP-1 and liquid oxygen, otherwise known as Kerlox, core stage, and even an incredibly advanced cryogenic upper stage, which burns liquid hydrogen and liquid oxygen, otherwise known as Hydrolox. This was only the 2nd orbital flight of this vehicle, and it went perfectly well, delivering the GSAT-29 communications satellite. This is good news as they work to certify this vehicle. Now, just before the end of the year, they firmed up and even advanced plans for the Gaganyaan crew program, further investing after seeing the success of the program this year. India is on track to become the 4th nation to put humans in space on their own vehicle. And that's a huge accomplishment. I see this as massively inspirational to India and the rest of the world. With India investing so much in their education, science, technology, and exploration, it's easy to see how they'll retain some talent in their country instead of losing talented and educated individuals who need to find work in their fields to other countries. This will have a powerful impact. So great job, ISRO. This is impressive progress. I can't wait to watch this program and the rest of your space program continue to grow. Rocket Lab had an incredible year. They had their first successful orbital flight, their first commercial launch, a NASA mission, they opened up a new factory, they leased a new launch pad in the United States, and they're on track to be launching just about every month from here on out. Whoa. So let's do a real quick little rundown. Rocket Lab is a New Zealand/American rocket company who produces the coolest black rocket ever, the Electron. The Electron is an amazing rocket which uses incredibly advanced manufacturing techniques such as entirely carbon composite tanks and fuselage, 3D printed rocket engines, and electric turbopumps to power those engines. On January 21st, Rocket Lab successfully launched their Electron rocket into orbit for the first time for their mission still testing. This was their 2nd flight altogether. After their first flight, it's a test, which was actually going perfectly smooth, but an error from the ground tracking station forced them to abort around 6 minutes into flight. After still testing, Rocket Lab prepared to ramp up with an impressive launch cadence. They got their next Electron out to the launch pad in April and prepared for flight. After several attempts, Rocket Lab made a decision to stand down in June due to an error they noticed on one of the flight computers on one of their 9 Rutherford engines on the first stage. Rocket Lab held off for a while as they completely redid their entire flight computer system, which is a good thing because they have a busy manifest. They definitely figured it'd be better to get it right and do the work now before they have the same issue potentially crop up on any other rocket. But then out of nowhere, Rocket Lab opened up a massive new rocket factory in Auckland, which is stunning. Look at this place. This should win the Leo just because it's so 21st century rocket factory / evil lair, and I love that. Okay, fast forward to November 11th, and Rocket Lab successfully launched their first commercial payload for the mission It's Business Time, launching 6 small and CubeSats. The mission was flawless, and they even played some really pretty music during their coast phase.
Enjoy these sweet tunes from Tim Dodd, the Everyday Astronaut.
Rocket Lab closed the year with a third launch, this time for NASA, and again, it was perfect. The pace of this company is mind-boggling. Look at how many rockets they have lined up and ready to go. They claim they're going to be ready to launch every couple of weeks, and I have no doubt they'll be on pace to be one of the most prolific launch providers already in 2019. Congrats to an extremely exciting year, Rocket Lab. I love your rocket. I love your factory. I love your fun, go-get-em attitude. I love the music during your live stream, and I can't wait to see what you've got up your sleeves next year. What happens when you put a tiny little payload and put it on top of the biggest, most capable rocket flying? Well, you break speed records and get a fascinating mission to the sun. That's what you get. Parker's Solar Probe is a daring NASA mission to visit the outer corona of the sun. This launched on August 12th on top of a Delta IV Heavy out of Cape Canaveral Air Force Station in Florida. PSP is only 685 kilograms, which is small enough to have launched on a Falcon 1, at least to low Earth orbit, but when you put it on top of the most capable rocket flying, you end up with enough energy to send this probe closer to the sun than any other mission to date. Parker's Solar Probe already broke the closest to the sun record on October 29th, and it will continue to get closer and closer to the sun after 7 additional gravity assists from Venus over the next 7 years. When the probe approaches the lowest point in its orbit around the sun, otherwise known as the perihelion, it turns off communication and just records data. During this period, it autonomously points its heat shield, which is actually just 99% empty space, directly at the sun to protect the spacecraft during the most intense portion. It'll be measuring the electromagnetic fields using what I can only assume is something used to power a flying car in the future, a flux gate magnetometer. It also has an instrument that will measure plasma, energetic electrons, protons and heavy ions, some optical telescopes, a solar wind detector, and a whole bunch of other really awesome science instruments. This is one of those missions that I think will answer some questions about the sun that we didn't even think to ask. There's a lot of unknowns about stars, and by directly observing the corona, we'll have more data than ever before. The engineering that goes into getting a spacecraft this close to the sun, the incredibly genius Venusian gravity assists that some brilliant people figured out, and the scientists who thought up the awesome science experiments is definitely applaud-worthy. So huge congratulations to NASA, Johns Hopkins Applied Physics Laboratory, and the United Launch Alliance for a beautiful start to an exciting mission. SpaceX had a huge year. Not only did they break their personal record for all their launches at 21, they actually launched the second most rockets period, coming in just behind the entire nation of China. But they even ended up launching more rockets than all of Russia. But as if that wasn't enough, SpaceX debuted their ultimate Falcon 9 rocket known as Block 5. The Block 5 version is what will be launching those astronauts for NASA's Commercial Crew program, as we mentioned before. Block 5 has been the culmination of over 50 flights of the Falcon 9, taking lessons they learned from all previous iteration changes. They painstakingly inspected all recovered boosters after dozens of successful landings. The goal is to have a booster that needs little to no refurbishment for up to 10 launches and is capable of 100 launches before retirement. This is a paradigm shift in rockets. Now, of course, the space shuttle was reflown, with the most flights going to Discovery, which flew 39 missions, and of course, that's very impressive and groundbreaking. The problem was the amount of refurbishment, which was intense. As a matter of fact, the quickest turnaround time for an orbiter was 54 days, which is great. That was with a Atlantis orbiter between STS-51J and STS-61B. But the usual turnaround time between flights was around 6 months. The amount of time spent refurbishing them was 650,000 hours of labor. Yeah, let me say that again. 650,000 hours of labor to refurbish them. That right there really is the biggest key to Block 5. SpaceX founder Elon Musk says over and over the key to bringing down the cost of spaceflight is rapidly reusing rockets. He claims their goal is to refly a rocket within 24 hours someday soon. Although the Falcon 9 has yet to break the space shuttle's record turnaround time of 54 days, their quickest turnaround time to date is 71 days. But they did achieve an important milestone with Block 5. For the first time, they reflew a rocket twice, making it the third time that rocket flew. Wait, that's really confusing. Put simply, they flew the same rocket 3 times. This is something they had never attempted with a Block 4 booster, and it's a promising glimpse into the future. This is all part of the big picture for SpaceX. Learn how to make spaceflight routine, rapidly reusable, and reliable. We're watching a company learn before our eyes and apply those lessons learned to make a better rocket. We even saw the first landing failure of a Block 5 this year, and unfortunately it was a brand new core that had only flown once on CRS-16 on November 5th. This was an awesome landing failure though, with a soft landing just a kilometer or so off the landing pad, touching down softly in the ocean. It was really cool to see the smart landing profile SpaceX developed. It proved that even a failing landing system will keep people safe. It was awesome to watch the rocket continuously try to regain control, despite the grid fins locked in a very, very unfavorable position. SpaceX also debuted a new composite overwrapped pressure vessel, or COPV, that NASA needs them to fly 7 times successfully before putting people on board. This is a result from that 2016 loss of a Falcon 9, which had a COPV blow up on the launch pad, completely destroying the rocket, the payload, and the launch pad. So congrats SpaceX on all the hard work that went into Block 5. I can't wait to see it fly over and over and over again, and also to fly humans next year. We made it to Mars! Yes! NASA had a home run trip to Mars for their InSight mission, making it only the 10th spacecraft to successfully land on the surface, and the first successful landing in 7 years. On May 5th, a United Launch Alliance Atlas V rocket took off from Slick 3E launch pad in Vandenberg Air Force Base in California. This was the first interplanetary mission from the US to launch from Vandenberg instead of Florida. The reason they did this is because the Atlas V rocket that launched it, even in its least powerful configuration, had plenty of power to get the 700-kilogram InSight lander and its cruise stage to Mars. And that's despite the fact that there's a performance hit by launching from a polar orbit, like those launched in Vandenberg Air Force Base. So why did they launch it from Vandenberg? Well, it was advantageous to launch from the much less busy Vandenberg Air Force Base than it is to launch from Florida's busy Space Coast. Less launches to schedule around is always a good thing, especially when you have such a small window of around a month or so to get off Earth and get your way to Mars. After a 6.5-month coast phase to Mars, InSight began its entry, descent, and landing sequence. That's the terrifying moment when absolutely everything needs to go exactly as planned. But luckily for the InSight lander, NASA and Lockheed Martin had basically done this all before almost exactly with the Phoenix lander, which is a twin to the InSight lander, and landed 10 years earlier. First, InSight detached from the cruise stage, which provided course adjustments, power, and guidance during the transit to Mars. It then faced the Mars atmosphere heat shield first as it prepared for entry. Welcome to the 7 minutes of terror. This is the time it takes to go from the upper atmosphere of Mars down to the surface, and there's a lot of pre-programmed sequences that need to go off perfectly during this period completely autonomously. First, the heat shield bled off 90% of the velocity before InSight deployed a parachute, which again removed another 80% down to just 420 kilometers an hour before InSight popped off its heat shield and backshell and used thrusters to make a nice, soft touchdown. And at this point in time, we got lots of cheering and this awesome handshake. Since there's such a large communication delay of about 8 minutes, us back here on Earth didn't know what happened to the spacecraft during this period until well after it happened. So everyone on Earth was just cheering for something that happened in the past, which is just kind of fun to think about. Now that InSight is safely on Elysium Planitia, a smooth plane just north of Mars' equator, it's already getting busy doing some never before done and super exciting science. InSight is the first lander that will study the core of Mars with some extremely sensitive instruments, including a probe that will actually burrow itself 5 meters deep, a seismometer that can precisely measure Mars quakes, a radio science experiment that will measure Mars' rotation precisely, Mars' weather, and a few other awesome science experiments. I know this might seem kind of funny, but I think one of my favorite things about this mission was the 2 CubeSats, Marco A and Marco B, which flew by and provided real-time communication during InSight's EDL, Entry, Descent, Landing. Why is this so cool? Well, here are 2 briefcase-sized CubeSats that had enough power to relay communication back to Earth during the most terrifying portion of the mission. If they weren't there, InSight would have had to relay information via the Mars Reconnaissance Orbiter, which doesn't transmit information nearly as quickly. I think that's super smart, taking your own communication satellites with you. I mean, imagine when we first send humans to Mars. We're going to want communications during the entire mission, including entry, descent, and landing. I mean, this will ensure there aren't further delays in communications or periods where we don't have data. These CubeSats didn't enter orbit around Mars. Instead, they just flew by Mars, providing that valuable uplink. Pretty stinking cool, if you ask me. All in all, InSight is just at the beginning of its exciting mission. This is one of those picture-perfect NASA missions where absolutely everything went perfectly. I'm excited to see what more we learn about Mars as InSight continues to deploy its science instruments and prepares for a flood of exciting data. So congratulations to NASA, JPL, Lockheed Martin, United Launch Alliance, and all others involved in this amazing mission. You guys make it look easy. Falcon Heavy. I mean, to me, this was obviously one of the greatest space events of 2018. But I know there's probably some of you out there who are saying, okay, SpaceX fanboy, what's so great about a car going around the sun? Where's the value in that? Well, first let me remind you of why Falcon Heavy was awesome, and then I'm going to tell you why I think it was easily the most important spaceflight event of 2018. SpaceX has been aggressively pursuing rapidly reusable rockets, like we just talked about with the Block 5. And Falcon Heavy takes this up a whole nother notch. Normally, heavy payloads require exponentially bigger rockets to take them to their destinations, which of course means the cost goes way up too. So when SpaceX reuses a Falcon 9, they're able to reuse about 65% of the rocket. But with Falcon Heavy, they can reuse about 90% of the rocket, and that's a major paradigm shift. Okay, this is cool and all, but again, is this really more important than a flawless mission producing groundbreaking information on the surface of Mars, or getting up close and personal with the sun, or bringing back stuff from an asteroid? Although the scientific benefits of Falcon Heavy's demo mission might not go down in the history books, Falcon Heavy sent a wave through the general public, helping them dream about space perhaps for the first time in a while, or maybe even their first time ever. And then of course we get the question of why did a billionaire put his car in space? Well, the short answer is because. But the slightly longer version is because this was a demonstration mission of a brand new rocket. And a car is a lot more exciting than, say, some concrete or a hunk of steel like you'd normally see in a test flight. I mean, you don't want to put anything expensive or extremely important on top of a demo mission, because there's a good chance the rocket might go boom. I discussed this topic a lot in a video called Why Does Falcon Heavy Matter?, where I explain the importance of all this. But now, almost a year later, looking back, I think there's one thing that stands out the most. Look at this. Now, I know social media statistics in no way, shape, or form reflects engineering prowess or scientific significance, but it sure can be a great gauge of the public's excitement. I mean, just look at this. Can you guess when the Falcon Heavy flew? When's the last time a rocket's name became so pop culture, so familiar, and so recognizable? Finally, the public has been awakened to spaceflight again, realizing there are other rockets flying that aren't a space shuttle. Hundreds of thousands of people flocked to Florida to see the launch. Millions and millions of people watched the SpaceX live stream. As a matter of fact, it was the second most watched live stream ever on YouTube. Every news outlet covered the launch. It was on the headline of every newspaper and every magazine. I mean, people paid attention. And then there's this. This is the key to the wild and wacky Falcon Heavy mission. I mean, look at that juxtaposition. A car meant to spend its days driving around the streets here on Earth, suddenly floating away into space. This is something we're all familiar with. We can all relate to, and with Starman in their SpaceX spacesuit there too, we can actually get a really strong sense that we maybe never had before. Now, of course, scenes of astronauts on a spacewalk or walking on the moon are unbelievably impactful and inspirational, but it honestly is so foreign to us. We have a hard time actually relating to it. But a car? You know, we know what a car is. We've probably all been in a car, and we can imagine sitting in that seat, watching the Earth shrink off into the distance. This struck a major chord and resonates with my biggest mantra of why space matters. Space is the one thing that unites all of us humans together. It's the one border we share. Once you get out into space, you realize there are no boundaries. There is no division, and all of our petty politics and wars suddenly become hilariously irrelevant. Space exploration is us, uniting as one species, exploring the next frontier together. It unites enemies like it did during the Cold War with the Apollo-Soyuz missions. It sparks our imagination and quite literally opens up new worlds. So yeah, maybe sending up a car into space is silly and seemingly frivolous, but in the grand scheme of things, it might be one of those moments we look back at in the history books. This might not have been a Wright brothers flying the first airplane moment. This may not have been a Chuck Yeager breaking the speed of sound moment. This definitely wasn't an Apollo 11 moment. But perhaps for the first time in the 21st century, kids were huddled around a screen watching a spaceflight event. For now, this is my generation's version of huddling around a small black and white TV, watching the Apollo 8 astronauts orbit the moon for the first time. Almost exactly 50 years ago from this day, while orbiting the moon, Bill Anders took a photograph of the Earth rising over the lunar horizon. This famous photograph, called Earthrise, is quite possibly one of the most iconic images in all of human history. And perhaps my favorite thing about this picture is that every single human ever, dead or alive, is in this photograph, besides just three: Frank Borman, Jim Lovell, and Bill Anders, the crew on board Apollo 8. Although a mannequin in the driver's seat of a Tesla doesn't have quite the same significance as humans orbiting the moon, I can't help but think this image is quite possibly one of the most inspiring images of the 21st century. And just watch this. I mean, two boosters screaming back from the end of space and landing in tandem, coming to a soft touchdown side by side. I mean, listen to how excited people were.
Stick it! Stick!
Listen to the sonic booms. I mean, I just don't think there's anything cooler than this. And to be honest, that does actually matter a lot. By having an excited public, we can drive more people to pursue and support space exploration. And while this might help shape politics to support space exploration too, more importantly, it can make the difference in the industry with floods and floods of new talented individuals entering the space industry wanting to be involved. People that may have used their skills in, say, the motorsports industry might now work in the aerospace industry. Kids who thought about dropping out of college might now pursue aerospace engineering. Or maybe just one person out there realizes that anything is possible and gets inspired to pursue their own dreams. A new Apollo era is upon us. Space is waiting. All we have to do is get out there and explore. So thank you, SpaceX. Thank you for stirring up our imaginations, inspiring us, bringing tears to our eyes, exciting the public, and doing something just because it's awesome. Oh, and congrats on nailing the Falcon Heavy. I cannot wait to see it fly again. Thank you all so much for joining me in this year's Astro Awards. I know it was long. Trust me, it took me forever to script and shoot this. But I think next year we're actually gonna make some legit Leo trophies to give out. What do you think? I'm also considering doing these things live next year with an actual awards ceremony in a theater and inviting all these professionals to come out and accept awards in person. If this is something you think is a good idea, let me know, and maybe we'll start a Kickstarter or something to help with flights and accommodations for all those invited. And guys, I owe a huge thanks to each and every one of you. 2018 was absolutely incredible. I mean, I did things that I just still can't believe happened, and it's all thanks to you. It's thanks to you for watching. Thank you to you for supporting me. Thank you for watching my live streams, saying hi, encouraging me, even correcting me and teaching me so much. I humbly thank you for absolutely everything. I can't wait to show you what 2019 is going to bring. It's gonna be a huge year in spaceflight, and I've got some really exciting things up my sleeve as well. If you want to help me continue to do what I do and make it down to even more launches than ever before in 2019 and do lots of crazy stuff, trust me, consider becoming a Patreon supporter by going to patreon.com/everydayastronaut or check out my brand new web store with lots of awesome merch at everydayastronaut.com/shop. Thanks everybody, that's gonna do it for me. I'm Tim Dodd, the Everyday Astronaut, bringing space down to Earth for everyday people.